Hi guys, let's look at the next question. The next question that we do is question number 23. It says in the given figure AB is parallel to EF, parallel to CD. AB is 67.5, which means this is 67.5. DC is 40.5. AE is 52.5 till here only. And name three pair of similar triangles. So this is what I was talking about in the previous video. If you need to look at pair of similar triangles, then the first thing that you should look at is numerator to numerator. That's your trick one. Next, try and look at vertically opposite triangles, and then the last, try and look at triangles with common angle. And the last option should be adjacent. You should not look at adjacent for now. So let's look at vertically opposite. So I can notice that ADE and EDC are vertically opposite, and since these are parallel, which means this angle and this angle will be equal, and this angle and this angle will be equal because these are alternate angles. So this will be my first pair. If I want, I can write this down. So let's just quickly write this one down. So this is our first pair of similar triangles. So in triangle ABE and triangle DEC, number one, angle AEB is equal to angle CED, vertically opposite angles. And number two would be angle BAE is equal to angle DCE, alternate angles. Therefore, by AA test, triangle ABE is similar to triangle A is equal to C, B now equal to D, and E to E. So this is my correspondence. This gives me my first pair of similar triangles. So they wanted three pair, one done. So let's look at what will it help us find EC or EF. Let's see if this will help us in finding anything. Maybe we need to find EC, so this could help us find EC, and EF. No, this is not a part of EF, so we could figure out EC from here maybe. Let's see if this works. So in any case, let's write the correspondence or in terms of proportion in any case. So this is AB upon CD. AB given, CD given, we should be able to find. AB upon CD is equal to AE upon CE. We should definitely be able to find BE upon DE. This is CSST. Done. Let's substitute values. AB is 67.5, CD is 40.5, so the decimal goes away. So let me just write it without the decimal directly. So it will be 675 upon 405 will be equal to AE, which is 52.5 upon CE, which we need to find, which means CE is equal to 52.5 into 405 upon 675. 13 plus 5, 18, and this is 9. So divisible by 9 for sure. So 9 sevens are 63, that's 45. So 9 5, 9 fours are 36, that's 45. 9 5. Divisible by 5, 5 9, 5 1, 5 5. Divisible by 3, 3 3, 3 5. 5 1, 5 10.5. Therefore, CE is equal to 10.5 into 3, that's 30, 31.5. 31.5 centimeter. So we've got CE and we've got one pair done. So CE is 31.5. Done. Let's try and identify a second pair of triangle which will be similar. So first thing I told you was look at vertically opposite triangles. And then the second thing I said was look at triangle with common angle. So is there a triangle with a common angle? Well, I can visualize one. which is this big triangle ABC and this small triangle EFC. So this is one small triangle EFC, and if I continue this line, it becomes ABC. And in this case, angle C is common, and angle F will be equal to angle B here because these are corresponding angles. Let's just write this down. Before that, let me draw a rough diagram. Will be easier for everyone to understand. So this is ABC and this is EFC. C is common and F and B are equal because these are corresponding angles. So in triangle ABC and triangle EFC, a number, so this was point number 6. Let's go to point number 7. Point number 7 would be angle ACB is equal to angle ECF. This is common angle. And point number 8 would be angle ABC is equal to angle EFC. This is corresponding angles. Therefore, triangle ABC is similar to triangle EFC by AA test. Which means let's try and write the the ratio of sides or proportion of sides. So AB upon EF is equal to AC upon EC is equal to BC upon FC. We need to find EF. Maybe we should be able to find EF from this. So this is CSST. Let's substitute values. AB is given as 67.5. EF, that's what we need to figure out. AC not given, but now that we figured out EC, it will be equal to 52.5 plus 31.5. So 52.5 plus 31.5, that's AC, and EC we've calculated as 31.5. Let's just multiply and divide. Hopefully it won't be such a complicated calculation. So this is point number 12. It'll be EF will be equal to, if I take EF there, this becomes 67.5 multiplied with 31.5 divided by 52 plus 31, that's 83, and 84, that's 84. So 675 into 315 divided by 84. Let me just erase some part of the question here so I have space for me to write. I will erase the first part and I will write this equation here so that I have space to finish this question. So EF is equal to 675 into 315 upon 84 into 100. I took the decimals up. So this is divisible by 7. So 7 1 7 2 4s are 28 35. This is divisible by 7. 7 4s are 28. That's 35. So 7 5s are 35. Divisible by 3. 3 into 4. 3 into 15. Divisible by 5 into 3. 5 into 20. Divisible by 5. 5 into 4. 5 1s are 5. 17. 5 3s are 15. 25. 135. So nothing now. EF is equal to 135 into 3 upon 16 centimeter. That 300, 390, 15. 405. 405 upon 16 centimeter. Need to write the answer in a simpler form. Mixed fraction. So 16 into 2, that's 32. That's 85. 60 into 5 is 80. That leaves 5. So 25, 5 upon 16 centimeter. Interesting question. Good. Let's look at the next question. The next question that we do is question number 24. Let's look at this question. Question 24 says QR is parallel to AB. QR is parallel to AB and DR is parallel to QB. So the tilted line. These two lines are parallel. We need to prove PQ square is equal to PD into PA. So let's just write it in the form that will help us. PQ upon PD is equal to PA upon PQ. So does this work? PQD is, I'm looking at PQA. PQA, straight line, doesn't work. I will ignore this trick. Let me just look at the other line. In case I had PQ upon PA is equal to PD upon PQ. So now I'm looking at PQD, which is again along a straight line. Doesn't help me at all. So which means this first trick that I use doesn't work in this question. So now let me try triangle with vertically opposite. So there is no vertically opposite triangle in this question. So let me try the third one, triangle with a common angle. And this is where I strike gold. I notice PQR, which is the small triangle, and if I continue with PQ, I look at this big triangle PAP. So will it help? I don't know. Let's try. So in triangle PQR and triangle PAB, this has two triangles have one thing in common, which is the angle P. This is PQR and this is PAB, and we've been given QR and AB are parallel. Angle P is common, so angle Q and angle A here would be equal because these are corresponding angles. So this angle here and this angle here are equal. We've already got our answer. So at least this part, I don't know how it will help us. So angle QPR is equal to angle, why didn't it write? Let's rewrite it. Angle QPR is equal to angle APB, common angle. Next part, angle PQR is equal to angle PAB. These are corresponding angles. So what this means is, therefore triangle PQR is similar to triangle. P corresponds to P, Q corresponds to A, and R corresponds to B. So which means I've got my two triangles similar. Let's see what this will give us. So what this will give me is, this is by AA test. What this will give me is a ratio or proportion of sides, which is PQ upon PA is equal to PR upon PB is equal to QR upon AB. This is CSST. PQ upon PA is equal to PR upon PB is equal to QR upon AB. Done. How would this help me? I have no idea yet. I don't have a PD. I have a PA here, so I will need to get it equal. So I need to get it equal to PQ here somehow now, and I need a PD here. Yes, if I look at this, I've got a PQ and I've got a PA, which means PQ here in the denominator is missing and PD here in the numerator is missing. Let's see if I can get anything else, and let's try and identify another set of triangles which will have common angle. So now I'm looking at these two tilted triangles, which is PDR and PQB. Again, these are pair of parallel lines and I have angle P common. So let me draw them separately. It will be easier for us to identify. This is P, this is D, this is R, and I have the bigger triangle which is PQB. This is DR is parallel to QB. Again, angle P and angle P are equal, and I will get angle Q and angle D equal because these are this angle are corresponding angles. So let's just write this down. Number 5, in triangle PDR and PDR and triangle PQB. Not need to work. Anyway, number 5 that I get is PDR is what we've taken over first. So angle DPR is equal to angle QPB. This is common angle. What this means is second one, angle PDR is equal to angle PQB, again corresponding angles. Therefore, triangle PDR is similar to triangle P equal to P, D equal to Q. So PQB, this is by AA test. What this gives me is number 8 in terms of proportion. PD upon PQ is equal to, this is what I wanted, PD upon PQ, done. But let's see how will I move from here. PD upon PQ is equal to PR upon PB is equal to DR upon QB. So this is equation number 8 and I already have a equation number 4. Is there anything which is equal here? PD PQ? No. PR PB? Yes, I noticed that PR and PB and PR and PB here are same. So since, well, not since, from 4 and 8, what I get is PR upon PB is equal to PQ upon PA and it is equal to PD upon PQ. So let's just combine these two and what I get is PQ square is equal to PA into PD. Not PB, PD. Very interesting question. We were unable to move from here using our trick. So then we identified two pairs of triangles which could be proven similar and we moved on and we got some answer. I forgot to write CSST here. Done. Let's look at the next question. The next question that we're doing is question number 26. It says AP is to PB is equal to 4 is to 3. So let's just assume, let's just let AP is equal to 4. So where is AP? This is 4x and PB is 3x. So that's point number 1. Let AP is equal to 4x. Therefore, PB is equal to 3x. Done. PQ is parallel to AC. PQ is parallel to AC. Okay. We need to prove we need to calculate the ratio of PQ is to AC. So since this and this is given, these will have to be in separate triangles. In any case, let's look at this big triangle because what we need to find is the ratio of PQ, which is here, and AC, which is here. So AC is a part of this big triangle and PQ is a part of this small triangle. Like I said, identify triangles which will have similar or which will have a common angle. So I have already identified PQB, the small triangle, and P remains the same, and ABC. Let's just draw these two triangles separately. This is CAB and this is QPB. Angle B is equal, and since these two sides are parallel, which means angle P here and angle A here will be equal because these are corresponding angles. Perfect. So in triangle ABC and triangle PQB, let's see what we have. Number 1. 1 is already gone, so point number 2. Angle ABC is equal to angle PBQ. This is common angle. Next, angle BAC is equal to angle BPQ. This is corresponding angles, which means therefore triangle ABC is similar to triangle A was equal to P, B equal to B. So this is PBQ. What this is by AA test. What this gives me is AB upon PB is equal to AC upon PQ is equal to BC upon BQ. CSST. We need to find PQ upon AC, which means this is what I need to find, and AB is given equal to, alright, AB is given equal to 4x plus 3x. So 4x plus 3x, that's 7x. PB is given equal to 3x, and AC, We don't know, that's the ratio we need to find. AC upon PQ, which means 7x upon 3x, which means 7 upon 3 is equal to AC upon PQ. They want ratio in the other form, which means I'll have to do the other way around, which means PQ upon AC is equal to 3 upon 7. Is this the final answer? No, if I leave the answer here, I lose a mark. Why? Because they have asked the question in the ratio form, so I write my answer in the ratio form, which means PQ upon is to AC is equal to 3 is to 7. That's my answer to part 1. Done. Let's look at part 2. Angle ARC is equal to 90 degree. So ARC, which is this angle, is 90 degree, and PQS or PSQ, what angle is given? I copied the question incorrectly because I have marked PSQ as 90. Let me just look at this. PSQ, I have written the question incorrect. This is not PQS, this is PSQ, because I have marked this here correctly, but I wrote PQ. Okay, so calculate the length of AR. So what are we looking at is AR, which is this. So I need to figure out which triangle should I look at. So this is the line that I need to figure out, and this 90 and this 90 is given, which means I will have to look at a triangle to prove them similar, and since this line and this line are given parallel, which means I should be looking at ARC, this triangle where one angle is 90 and is parallel. So this line has to be in focus and this triangle. So yes, I am looking at SPQ and ARC because I will get one angle 90 and this line are parallel, which means I should be able to get a corresponding angle equal. Let's just write this down. In triangle ARC and triangle PSQ. Let's draw these two triangles separately. Let's redraw. This is R, this is A, this is C, and this is S, this is Q, this is P. This side and this side are parallel, one angle equal, which is 90. If I look at AC and PQ as parallel lines and CQ as the transversal, no, it doesn't work. Any other angle which I can prove equal? Yes, I can get, if AC and PQ are parallel and I look at CR as the transversal, then I'll get this angle and this angle as equal because these are alternate angles. So I am looking at this angle here and this angle here. Let's just write this down. This is point number 10. Angle ARC is equal to angle PSQ is equal to 90 degree. This is given. Next part, angle ACR is equal to angle QPS. These are alternate angles, which means triangle ACR is similar to A equal to Q, C equal to P, and R equal to S. This is by AA test, which means I will get AC upon QP is equal to AR upon QS is equal to CR upon PS. CSSP. Okay, and I will have to erase the first part of the question for me to be able to get the solution. So this is point number 14. AC is the length of AC given in the question. No, AC is 7. Yeah, why is AC 7? We got it from previous one. We got AC is to PQ as 7 is to 3. Right? We got AC is to QP as 7 is to 3. So from 7 AC upon PQ is 7 upon 3. So put this in number 13. So this would be 7 upon 3 is equal to AR upon QS. QS is given equal to 6, which means AR is equal to 6 into 7 upon 3 centimeter, 1, 2. Therefore, AR is equal to 14 centimeter. Very interesting question. What we figured out in part 1 is what we had to use in part 2. Wonderful. Let's look at the last question of this exercise that I'll solve with you. The last question of this exercise is question number 28. It says medians BD and CE, okay, which means AD and CD are equal. This is dividing it into two equal parts. And CE, which means AE and BE are equal, dividing it into two equal parts. We need to prove EGD is similar to CGB. So this small triangle here and this big triangle here. So again, this should be simple to prove. These are vertically opposite triangles. Should be simple. Let's just try. So in triangle EGD and triangle BGC, what I have is number 1, angle EGD is equal to angle CGB, vertically opposite angles. Is there anything else given? No, nothing else given. It's only given that these are ratios are equal, or maybe I can use something that I've learned earlier. Since this is midpoint, E is midpoint of AB and D is midpoint of AC, I'm joining two midpoints. So what will I get? Yes, I will get a line which is parallel to the third side and it will be half of the third side. Yes, this is midpoint theorem that we did in class 9, or was it in class 10? I don't really, I think it was class 9. Yes, we did midpoint theorem in class 9. So let's just write this down. Since E is midpoint of AB and D is midpoint of AC, therefore ED is parallel to BC. That's using midpoint theorem, using midpoint theorem. And number 4 would be ED is equal to half BC. This is what we get from midpoint theorem. So which means ED is parallel to BC. Now if ED is parallel to BC, my life becomes simpler because in this triangle, angle D and angle B now become equal. So now I'll write number 5, angle EDG is equal to angle CBG. These are alternate angles. So from point number 1 and point number 5, I get triangle EGD is similar to triangle CBG. No, so if G is corresponding to G, CGB by AA test. So this part is done. This is answer to part 1, hence proved. Done. Let's look at the second part. Our second part is BG is equal to 2 times GD. Well, this is a property of median that we've done in class 9 as well, that the point where the medians intersect, that point divides the median in the ratio 1:2. But they are asking us to prove it. And since we are in the chapter similarity, let's try and prove it using similarity. So here, from this, what I get is EG upon CG is equal to ED upon CB is equal to GD upon GB. This is CSST. Done. But I know here that ED is equal to BC is equal to 2 times ED, correct? ED is equal to 2 times BC. So from 4, what I get is ED is equal to half BC, which means ED upon BC is equal to 1 upon 2. Yes, ED upon BC is 1 upon 2. So from 7 and 8, if I combine this, I get EG upon CG is equal to ED upon BC is equal to GD upon GB equal to 1 upon 2. We want BG and GD. Between BG and GD, we combine this, and what we get is BG is equal to 2 times GD. Hence proved. This is answer to part 2. Very interesting. Use the property or use the theorem that we done earlier. This can also be proved using similarity, but I thought that this would be easier understood and simpler done using midpoint theorem. Good. Let's look at the homework question. The homework question for you would be question number 27. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye bye.